So we have a problem here. City tower. Let's quickly read the prompt. Surface. A point moving may move to any below. Okay, now here BCDE is basically 4 directions they are specifying us. Wait, it's 2D surface, right? 2D surface. So let's draw the coordinate. This is origin. So they are telling us that if there is a point ax comma y, it could move this way, left side, or down. These are the 4 possible ways a point or a vertex in this case can move. Okay, they have specified us that they okay. Although second is distance from origin should increase with each move. Distance from the origin for the vertices is this. Okay. This is 1, this is 2, this is 3, this is 4, this is 1, this is 2, this is 3, this is 4. So basically they are telling us that the distance from the origin should increase with each move. And how it can move? It can move only in 4 direction. So basically if we go from here, let's suppose this, then this, then this, then this, then this, then this, then this, but you cannot move this way. Now this is not acceptable because it's telling us that the distance should always increase. So either you are going this way or you are going this way. Of course, in first quadrant. In second quadrant, you are gonna go this, like this way, or always increasing the distance from origin. Same with the third quadrant and fourth quadrant. Yes. So let's find out what we have to find out. Distance is okay. Now distance is also specified here, that if we are at the point a x comma y, then the distance from the origin is x plus y. Okay. Both the rules should be satisfied for each move. Okay. That means we always have to move like this. We can never move backwards, because if we move this like this or this, then the coordinate of x or y gets shortened by 1 unit. That would ultimately reduce the distance overall, this distance. So we cannot do that. Okay, that actually makes the problem easier, because if we were to go backwards, that would have been hard. That actually would be very hard. Oh, okay, both the rules should be satisfied. Okay, now what we have to find for a given number of steps n. Okay, now we have to take steps n first. Calculate the count of possible final positions, vertices, you may end up in if you initially started from the origin. Okay, let's go dialogue by dialogue. What it's saying. First we have to take n steps, right? Yeah. Okay. This is origin. This is 1. In which direction should we take? Should we take in x direction or y direction? Both are equally. Let's take y. This is 0, 1. This would be 0, 2. Likewise, let's take n steps and found ourselves on 0, n. Okay. Now this distance is n, of course. Now what we have to do for a given number of steps n, we have taken n. Okay. Calculate the count of possible final position vertices you may end up in if you initially started from origin. Okay. So basically what that second statement is telling us, that we have to find how many points we could figure out in this region. We can find out in this region quadrant 1 that would count for possible final position when we initially started from the origin. Okay. Now we have started from the origin, and what is the distance now? N. Now we have to maintain this n distance throughout. We have to find points which should maintain this n distance. Okay. Wait, am I doing something wrong? No, it's all right. We have to take n steps, and we have taken n steps. And what is the distance that we have covered in n steps? Distance in n steps. What is it? N. Yes. Now, okay, let's do some PNC. This point is 0, n. Now let's suppose there is some point which is, let's say, 1, n minus 1, right? Yeah. Now if we were to find out this points 1, n minus 1's distance from the origin, what is it? It's 1 plus n minus 1, 1 plus n minus 1, which is n. Okay, so it would form a line. Okay, so we have to basically, there is a point 1, n minus 1, and there has to be another point like something here, 2, n minus 2. Of course, this is n, then this is n minus 1, this is n minus 2. Karte we can go down till 2 and 1. So here also it's 1, 2 till something n minus 1 and n. Now there is also something here, 3, n minus 3, till we found ourselves here, which would be point n minus 1, 1. And here is our final point, n, 0. Okay, so what have we done is we have to find the points which are, let's say we have to find point A in which x plus y, which is distance from the origin, is equals to n, because we have taken n steps. It's given in the question for given number of n steps. So now it's very easy, I guess, because let's count the points 0, n, 1, n minus 1 till n minus 1, 1. Now okay, now we won't take n, 0, because it's same, right? 0, n and n, 0, it's not same, but when you would try, if we are including this, then this would be the line, and there has to be another line here also, same, then here too, and here too. It would basically be 4 line type. So this n, 0 would be in this, it would be included in this section, and similarly there would be we would not include this, and this would be included in this section, and we would not include this, and this would be included in this section, like this, and we would not include this because this is included in first quadrant section. Okay, so 0 to n minus 1, 1, we are basically here. How many how many points? It's n points. Okay, so the question is solved, I guess. So number of points in first quadrant is, first quadrant number of points n, so in second and third and fourth also n points. The whole total 2D space we have 4 n points. Okay, question is solved, I guess. So 4 n points. Let's write. Oh, we have input cases, right? We can map that. 3, 12. Yes, see, 3 is the number of steps we have to take, and there is 12, because 3 into 4, 12, 1 into 4, 4. Yes, it's perfectly right. No, you can see the explanations, but it's basically what I've told you, that it would make a line. If you plot all these points on the 2D space, it would give us the line, and that's what I've already mentioned here, that this would produce this line. So total 4 n points. Code is very simple. We just have to display 4 n. The basic logic of this was this. Oh, sorry, make you understand this, I guess, this part, I guess, yeah. And moreover, that you have to understand that the point cannot move in backward direction, because if it would move in back direction, then probably the question would be very hard, because then it would actually form. Okay, that would actually be tough to calculate. I'm not even going into that. Okay, now let's write the code. Code is very simple. The main logic behind this question was that you use actually your this knowledge of graphs to understand the question. There is test cases, right? Wait a second. we have test cases? Okay, test cases है. Okay, cool. T minus basically we have to indent C in N, then we have to C out is basically 4N, right? Yeah, so now that's the whole code, and properly we have to put it there. Yeah, I guess this should does it. This should do it. 2 test cases, 3, 12, 1, 4. Yes, cool. Copy this, paste it here. Okay, no such directory. Oh, yeah, sure. There isn't any directory in C. Yep, passed. Submit the code. What? Input 1. What is input 1? 12 till here. Oh, I guess I haven't done a long int, right? Yeah. We have to actually take it in long int, I guess. Yeah, that should do it. Yep, that should do it. Submit code. Yep, accepted. Okay.